Okay, here's another velocity versus time graph where we're asked to find the acceleration and the displacement. First thing we'll notice is that the slope changes, so there's going to be two different accelerations, one for the first 100 seconds and one for the next 100 seconds. So if we want to find the first acceleration, we're just going to find the slope here. So it appears to be a fall of negative 50 meters per second and a run of 100 seconds. So the acceleration over this first part is negative 50 over 100, or negative 0.5 meters per second squared. Over the second region, it appears to be a fall of, it's going to be negative 100 is the change in the height, technically meters per second, over also 100 seconds, so that will be negative 1 meters per second squared for the second region. So those are the accelerations. It's a larger acceleration on the second part of the graph, bigger magnitude as we can see from the 1 compared to the 0.5. But now let's get into a little bit more of a complicated thing, and that is the displacement of the object. So in the last video we said displacement could be found by finding the area trapped under the curve. So the tricky part here is we actually have some negative velocities. So in the first part, the velocity is positive, and so the object is going to be going to the right. So we're going to be looking at this area trapped by the curve and the x-axis. What's tricky is on the second part of the graph, now the velocity is negative. It is below 0, so it's going to the left. And the area trapped is actually going to be this area, again, trapped by the x-axis and the curve. And what's interesting about this area is this is actually going to be a negative area, and you'll see why in a second. So let's find the area on this first region. So again, it's a triangle, so the area is going to be 1/2 the base, which is 100 seconds, times the height, which is 50 meters per second. So if I do that all out, 100 times 50 times 0.5, I get 2,500 meters. And since this was above the x-axis, we're going to say it's a positive 2,500 meters. In other words, the object was going to the right, and it managed to travel 2,500 meters to the right. Now the next part, if we do it, it's also a triangle, so it'll be 1/2 the base, also 100 seconds, times the height. And you might say, well, the height is 100, but technically this is now negative meters per second, because we're in the negative region. It's a negative velocity. So that's going to change our answer. It's going to give us a value of negative 5,000 meters. In other words, during this period of travel, the object actually traveled 5,000 meters in the other direction. So for the first 100 seconds, it traveled 2,500 meters to the right. For the next 100 seconds, it traveled 5,000 meters to the left. And this should make sense because it was accelerating more quickly over the second region. If you look, the average speed on the first part of the region was right around here, about 25 meters per second in the positive direction. The average speed on this was about negative 50 meters per second was the average velocity. So it's going to travel more in the other direction. So to find the total displacement, we just add these two values together, positive 2,500 and negative 5,000, and you get negative 2,500 meters. So in the course of travel, this object traveled 2,500 meters to the left. And that's basically how you would do a problem like this. A little trickier than the last one we did. So just watch yourself on those signs. So until next time, I am Derek Genova. Have a delightful day.